Good afternoon, students. This is Pragnesh Polara from OM Engineering College again. In last session, we have discussed some examples of limits using factorization, using conjugates of limit at infinite, and then we have started some standard limits of algebraic and trigonometric functions, in which we have discussed one special kind of limit, which is limit x tends to infinite, limit x tends to a, x raised to n minus a raised to n upon x minus a is equal to n a raised to n minus 1. And we have also discussed one example which is based on this limit formula. Okay, so let us look at one more example which is based on this kind of formula. So next, if we look at next example, the question is evaluate limit x tends to minus 1 x raised to 27 plus 1 upon x raised to 24 minus 1. Okay, so here it is clear that this is the example based on this formula, because here if we look at the index of x, that is 27, so if we try to solve this example using factorization, then it is very tough to factorize when this is x raised to 27 and this is x raised to 24. In this kind of situation, it is quite easy to use this formula. Here we can write this example is like this. This is x raised to 27. As per our formula, we need x raised to n minus a raised to n. Okay, we need here minus, and here that is plus. So we will plus 1 is equal to minus into minus 1. So we can put here minus 1. So that is plus 1, and here we will write x raised to 24 minus, that is 1. Okay, and here if we compare this one with our formula, this is limit x tends to a, so here a is equal to minus 1. We will notice that here a is equal to minus 1, and in the numerator we have minus 1, but in denominator we have in bracket plus 1. So we need to convert it in the minus 1 format. So limit x tends to minus 1, here x raised to 27 minus, here note that 27 is odd power, right? So if we put the odd power of minus 1, then we will get the answer minus 1. Okay, so minus 1 raised to 27, that is equal to minus 1. So we can write here minus 1 raised to 27 instead of minus 1. So that is same. Okay, and here x raised to 24, we know that 24 is even power. So minus 1 raised to even power, that is equal to plus 1, and we have here the plus 1. So we can put here minus 1 raised to 24, because minus 1 raised to 24, that is equal to plus 1. So we can put minus 1 raised to 24 instead of plus 1. So we have solved one problem. આની અંદર એક પ્રોબ્લેમ એ હતો કે અહીંયા વચ્ચે માઇનસ હોવું જોઈએ, કેમ કે અહીંયા પ્લસ હતું તો આપણે માઇનસ જોતું હતું, એટલા માટે આપણે માઇનસ 1 લખ્યું. ફર્સ્ટ પ્રોબ્લેમ ઇઝ સોલ્વડ. સેકન્ડ પ્રોબ્લેમ હતો કે અહીંયા a ની જગ્યાએ છે -1, તો આપણે અહીંયા -1 જોતું હતું, એટલા માટે આપણે 1 ની જગ્યાએ લખેલું છે -1 રેઝ ટુ 24. તો ફર્સ્ટ બંને જગ્યાએ એક પ્રોબ્લેમ સોલ્વ થઈ ગયો કે બંને જગ્યાએ એક્સ રેસ ટુ એન માઇનસ એ રેસ ટુ એનનું ફોર્મેટ આવી ગયું છે. એ જગ્યાએ એની જગ્યાએ બંને જગ્યાએ -1 છે. તો એક્સ રેસ ટુ એન માઇનસ એ રેસ ટુ એન, અહીંયા એન ઇઝ ઇક્વલ ટુ 27 છે. અને ડિનોમિનેટરમાં એક્સ રેસ ટુ 24 માઇનસ એ રેસ ટુ 24, તો અહીંયા એન ઇઝ ઇક્વલ ટુ 24 છે. પણ હજી પણ જેમ આપણે લાસ્ટ એક્ઝામ્પલમાં ડિસ્કસ કરેલું કે અપોન એક્સ માઇનસ એનું ફોર્મેટ આપણે જોશે. જો આપણે આ ફોર્મ્યુલા યુઝ કરવો હશે તો એન એ રેસ ટુ એન માઇનસ 1. અહીંયા ન્યુમિનેટરમાં કે ડિનોમિનેટરમાં એક્સ માઇનસ એનું ફોર્મેટ નથી, તો આપણે ન્યુમિનેટરમાં પણ એક્સ માઇનસ એ લેશું અને ડિનોમિનેટરમાં પણ એક્સ માઇનસ એ વડે ડિવાઈડ કરશું. તો આપને મળશે લિમિટ x tends to -1 x raised to 27 minus -1 raised to 27 upon x minus -1, that is x minus a, x minus -1, which is equal to x plus 1. In the same way for the denominator, x raised to 24 minus -1 raised to 24 upon x minus -1, which is equal to x plus 1. Okay, and using the quotient law, this is equal to x tends to -1 x raised to 27 minus -1 raised to 27 upon x plus 1 upon limit x tends to -1 x raised to 24 minus -1 raised to 24 upon x plus 1. Okay, so this is in the already format of limit x tends to a x raised to n minus a raised to n upon x minus -1, that is x minus a. Okay, and same way for the denominator, here n is equal to 27, a is equal to -1. Here n is equal to 24 and a is equal to -1. So our answer is limit x raised to n minus a raised to n upon x minus a is equal to n a raised to n minus 1. So answer for the numerator is equal to n a raised to n minus 1, which is 27 minus 1, that is 26. So 27 into -1 raised to 26. And for the denominator, here n is equal to 24 n a raised to n minus 1, that is 24 minus 1, that is equal to 23. So we will get here -1 raised to 26, which is even power. So -1 raised to 26 is equal to +1. So this is only 27 into +1 is equal to 27. But in the denominator, -1 raised to 23, 23 is odd power, so that is equal to -1. So 24 into -1, which is equal to -24. So we will get here minus of 9/8. 9 into 3, 8 into 3, 9 3s are 27, 8 3s are 24. So that is equal to -9/8. So this is the whole idea of this formula, how to use the limit x tends to a x raised to n minus a raised to n upon x minus a. So in this kind of example, generally the denominator part, that is x raised to n minus a raised to n upon x minus a part, is generally not given. So we need to divide numerator as well as denominator by x minus a, and then giving the separate limit to the numerator and denominator, we will get two same kind of formula, limit x raised to n minus a raised to n upon x minus a. There is just the value of n is different for the numerator and denominator, otherwise the value of a is same. So we can use the same formula twice for the numerator and denominator to solve the example, and we will get quickly our answer. Okay, so in the same way we can solve one more example using this method. So look at one more example. Our question is evaluate limit x tends to -1 x raised to 2009 plus 1 upon x raised to 2011 plus 1. Okay, here we can directly decide that we need to use this rule, that is x raised to n. Our formula, I am writing the formula here, limit x tends to a x raised to n minus a raised to n upon x minus a, which is equal to n a raised to n minus 1. અહીં આપણે ડાયરેક્ટલી એ આઈડિયા આવી જવો જોઈએ કે આપણે અહીંયા આ જ ફોર્મ્યુલાનો યુઝ કરવાનો છે, કેમ કે ઇન્ડેક્સ જોતાં જ આપણે આઈડિયા આવશે કે અહીંયા ઇન્ડેક્સ 2009, તો ફેક્ટરાઇઝેશન તો પોસિબલ છે જ નહીં, તો આપણે અહીંયા આ જ ફોર્મ્યુલાનો યુઝ કરવો પડશે. તો અહીંયા આપણે સૌથી પહેલાં તો લખશું લિમિટ x tends to -1 x raised to 2009. First, here a is equal to -1, so we need x raised to n minus a raised to n, but here plus 1, so we will write here minus -1. In the same way for the denominator, x raised to 2011 minus -1, right? So that is equal to limit x tends to -1 x raised to 2009 minus -1 raised to 2009, because 2009 is odd number, so -1 raised to 2009, which is equal to -1 only, so we can write -1 raised to 2009 instead of -1. In the same way for the denominator, here x raised to 2011 is also an odd number, so we can put -1 raised to 2011 instead of -1. So here we have created the format x raised to n minus a raised to n for the numerator. Same way for the denominator, x raised to n minus a raised to n. Here n is equal to 2009, here n is equal to 2011. Okay, so but here our main part x raised to n minus a raised to n is clear, but we need x minus a, so we need to divide numerator as well as denominator by x minus a. So here we will divide by x minus -1, which is equal to x plus 1, so which is equal to limit x tends to -1 x raised to 2009 minus -1 raised to 2009 upon x minus -1, that is x plus 1, and same for the denominator, x raised to 2011 minus -1 raised to 2011 upon x minus -1, which is equal to x plus 1. Using the quotient formula, here we will write limit x tends to -1, the same terms, upon x plus 1, and here also limit x tends to -1 x raised to 2011 minus -1 raised to 2011 upon x plus 1. So this is our clear cut formula, x raised to n minus a raised to n upon x minus a. In the same way for the denominator, limit x tends to a x raised to n minus a raised to n upon x minus a. Here n is equal to 2009, here n is equal to 2011. 11. So what we will get here, n, that is 2009, a, that is minus 1, n a raised to n minus 1. So we will get 2009 minus 1, which is equal to 2008. Okay, upon here n is equal to 2011, a is equal to minus 1, and n minus 1 is equal to 2010. So we will get here 2010. Here note that 2008, which is even number, 2010, which is also even number. So minus 1 raised to any even number is equal to plus 1. So we will get here plus 1. So 2009 into plus 1 is equal to 2009, and same way 2011 into plus 1, which is equal to 2011. So our answer will be 2009 upon 2011 using our formula. So this is one more example of the same kind of formula. So this is most important rule for the point of view of limit example for diploma students. So this is one special kind of formula. Now we will quickly move to our next standard formula, and we will solve the example of finding limit using that particular technique. Okay, so our next formula is limit, the formula number 2. Okay, the special formula. Okay, this is formula number 2, which is limit h tends to 0, a raised to h minus 1 upon h is equal to log a to the base e. Before we solve the example using this formula, we need to understand that which kind of format is this one. To solve the example using this formula, we first need to understand and the requirement of these formulas. એટલે કે જો આપણે આ ફોર્મ્યુલાનો યુઝ કરીને એક્ઝામ્પલ સોલ્વ કરવો હોય તો એક્ઝામ્પલનો